Hey guys, so this is a step-by-step example of kind of a trickier problem using the first part of the Fundamental Theorem of Calculus, and this was a request, which you know I always take. So here's the problem. So it looks like this. So we're trying to find dy dx for y equals x times the integral of sine t to the third dt, and we've got these limits of integration from 5 to x squared. Okay, so just jumping right into this. So here is part one of the Fundamental Theorem of Calculus, and this really is, I've discussed this at length in other videos, so if you don't understand this theorem, I highly recommend that you go back and watch one of my videos where I kind of break down how everything works with this, because it is a little bit complicated. But the thing I'm going to remind you of here is this is kind of the big thing that we need from this. This is giving us the structure of how to take the derivative of these types of problems. And so I've talked about this at length in other videos. The big thing here is that you have x and a number here in your limits of integration. And so you can see then if I'm trying to take the derivative of this, it's really the same then. It's just plugging in x right into whatever function you have right here. That's what it's trying to get at. So if I look at this problem, this is not quite like what my theorem shows, right? So first of all, I don't have x here. Notice right here I have an x squared. And then to make things slightly more complicated, I also have an x right here. So I can totally take the derivative of this, but I'm going to have to think through all my derivative rules, and I'm going to have to use the product rule for this, where here's my first function, and here's my second function, so product rule. Okay, so let's go ahead and start this. So the product rule says that I'll take the derivative of the first function, and I leave the second one alone. So the derivative of x is just going to be 1, right? So what am I left with? I'm really just left with, let's see, here's 1 times, and then I'll just write out the other function like this. T cubed dt. Okay, so there's the first part. And then I leave the first function alone, so I just leave the x here. And now I'm going to take the derivative of this guy right here. Now, there's a couple of issues in that so I'm going to go ahead and plug in this x squared, but since this is x squared and not x, I have to use the chain rule here. So there's going to be kind of a couple of parts when I take the derivative. So actually, let me, just to give myself a little extra space, let me write this down here. So let's say plus x, and then I've got this integral, so x times, sorry, I'm like, okay, so x times. So first I'm just going to write out this function. So I've got sine, except now instead of it being t, I'm going to plug in this part right here, this x squared. So I'm going to write sine of x squared and then all of that cubed. And then I have to multiply that by the derivative of x squared, which is 2x. So this is actually everything that I need for this derivative. So I'm actually almost done now. So to finish this, now I have this integral here, and then plus, so this will come out to 2x squared sine of x to the 6th. So this probably looks a little bit surprising and goofy because it feels like when we're taking the derivative, we shouldn't have the integral, but it makes sense from the standpoint of the product rule if you're strictly applying it. So this is like totally a function. This is something I've talked about in other videos. So it's okay that we actually have this here in this case. We are properly using the product rule. And so that's actually it. That's the final answer. So if you found this helpful, consider liking my video or subscribing to my channel or leaving me a comment. I do take requests, so I always read your guys' comments, and any feedback you give me is helpful. Okay guys, I'll see you next time.